Chapter 3, Motion in a Straight Line. Motion in a straight line, we are taking question and answer of motion in a straight line. The first is, in which of the following example of motion can the body be considered approximately a point object? A railway carriage moving without jerks between two stations. So if two stations are long apart, then we can take the railway carriage as point object. A monkey sitting on top of man cycling smoothly on a circular track. So if it is a circular track, a monkey is on the top of a man which is cycling. So with respect to the circular track, the monkey, the size is less. So you can consider the monkey as a point object. A spinning cricket ball that turns sharply on hitting the ground. So now the ground, that is the pitch, if we are talking about pitch, the ball has a substantial size. Here we cannot take the spinning cricket ball as point object. A tumbling beaker that has slipped off the edge of a table. When you talk about a table and a beaker, then you see that this object is somewhat comparable to the size of the table. So you cannot take it as a point object. This is what is being discussed here. The position time xt graph for two children A and B returning from their school O. If this is a school, this is the graph of A, this is graph of B, and their houses are at P and Q. We have to correct the choose the correct entries from this A/B, A/B or B/A. The first is AB lives closer to the school than the BA. See, A has to go to P. So A is closer to O rather than B, because OP is less than OQ. A has to go up till this distance, right? So we can say that A lives closer than B. Then AB starts from the school earlier than BA. Here A starts at t equal to 0, but B starts afterward, after some time. So we can say that this AB means A starts from school earlier than B. So we'll choose A and then here B. AB walks faster than BA. See, the time A has reached here, the B, although he has started later, but he has crossed somewhere, or he has reached the house. What time we'll see, but he is walking faster, because as you see from the graph, this B walks faster than A. A and B reach home at the same time or different time. If you see here, if this is a time, so if you draw a line here for time or t, we see that both are same. So they are both reaching at the same time. AB overtakes BA on the road. So B overtakes A on the road because B is faster than A. So this is what is being discussed all here, that A lives closer than B, A starts from school earlier than B, B walks faster than A, and A and B reach at the same time, and B overtakes A once on the road. How many times they are meeting? Because they are just crossing once, so you can say they are crossing once. So B is overtaking A once. After that, they reach their home. A woman starts from her home at 9 a.m., walks with a speed of 5 km an hour on a straight road up to her office 2.5 km away. Stays at the office up to 5 p.m. Returns home by an auto with a speed of 25 km an hour. Choose suitable scales and plot the xt graph of her motion. So what is happening here is, the woman is starting at 9. Then by 9:30, this is the xt graph. So by 9:30 she reaches here at 5 km. Then she stay in office from 9 to 5. And then in just few minutes, because the speed of the auto is 25 km an hour. So she reaches at this time, 6 minutes actually. We'll find out this distance, or you can say we will find out the time also. This is the graph. We are choosing from 9 to 5, and in between also we can have 9:30, 10, 10:30 like this. Here, because we have to go up to 5 kilometers, so we have taken the x in kilometer till 5 kilometers. Now let us see what is happening. When she is walking Speed of the woman is 5 km per hour. The distance is from here to here 2.5 km, means from her house to the office. So the distance is 2.5 km. We know that t equal to d by s, time equal to distance by speed. We'll just put these two values and we say that this is 0.5 hour. 0.5 hour or half hour is just 30 minutes. Now she has to cover the same distance, that is 2.5 km will remain same. But now the speed has changed, it is 25 km an hour. Again we'll apply the same formula, it will be 6 minutes. That is 1 by 10, 1 by 10 is 0.1 hour, 0.1 hour, change it into minutes, 60, so it gives you 6 minutes. So this is the 6 minutes, this is the plotting of the graph. A drunkard walking in a narrow lane take 5 steps forward and 3 steps backwards. So 1, 2, 3, 4, 5, he takes forward and he comes back 1, 2, 3. So eventually he is taking only 2 steps per walk, coming and back, means moving forward and backward. So this happens again and again. Each step is 1 meter long and it requires 1 second. So 1 meter, one step, 1 second. We have to plot the xt graph of the motion. We have to determine graphically or otherwise how long the drunkard takes to fall in a pit 13 meter away from the start. So we have to start from here. We have to see how much time it needs for him to go up to this 13 meter. We know that every time he walks for 2 meter only, because he walks forward for 5 steps, then he comes back. So 2, 2, 2 like this, and just 1 meter is remaining. We'll see about that. The distance covered in 1 step is 1 meter and time taken is 1 second. As we said, the time taken to move first 5 meter forward, because 1 meter is 1 second, so it is 5 seconds. And time taken to move 3 meter backward, which is simply 3 seconds, because he comes back. So net distance he covers is 5 minus 3, as I suggested here, 2 meter. But as I said that he only walks for 2 meter, but 1, 2, 3, 4, 5, and then he comes back 3 again. So in all, 5 plus 3, that is 8 seconds he takes for one forward and backward step. So he covers 2 meter in 8 seconds, 2 in 8 seconds. So it will be 4 in 16 seconds. So it will be 6 in 24 seconds. Then 6 plus 4 plus like this. Okay. So we can just say that in 6 meter he is going 24 seconds. And you can also say that in 8 seconds he goes 32. This is simply, just in 2 it is 8. So what will be 4? In 4 we are multiplying 8 by 2. Here just simply, interpolating it. Now in 8 seconds he is walking for 32 seconds. Now we want for 13 seconds. So it has to be 8 plus 5. So 8 seconds we have obtained, it is 32 seconds. How about 5 seconds? So in 5 seconds the drunkard will cover 5 meters. So total distance of 13 meters. After that he falls to the pit. So 32 is this 32 seconds, then again 5 seconds he takes. So 32 plus 5 is 37 seconds. So this is how total value will be. Now the graph will be of zigzag, it will be quite easy. This is the time, this is the x. We have taken from 2 to 14. From here we have taken from say up till 40. Now he goes like this, then he returns like this. Then he goes like this, he returns like this. Means this is 5 steps, 5 seconds. Then again he comes back 3 steps, so 3 seconds, so it will be 8. Like this zigzag it goes. A jet airplane traveling at a speed of 500 km an hour ejects its product of combustion at the rate of 1500 km an hour relative to the jet plane. So if jet plane is moving like this, then it is, because the speed is 500 of the jet plane, it ejects the combustion, means you can say the smoke coming out of it, you can say like that, it is 1500 km an hour. What is the speed of latter with respect to an observer on the ground? So when the observer is here, he sees that because it is going at 1500 and this is at 500, so we'll see there will be a difference of these two. So the speed of the jet airplane is given as 500 km an hour, but if this is plus, this has to be negative. So this is the relative speed of the product. This product which is coming out of combustion with respect to the plane will be what? This is minus. If this is plus, this has to be taken minus. So we smoke you can say will be minus 1500 km an hour. Now speed of the product of combustion with respect to the ground will be what? For him, let us assume to be V dash smoke. And we know that the relative speed of its product of combustion with respect to the plane will be what? V smoke will be simply V dash smoke minus V jet. We want to find V smoke, so just take this one here. It will be minus 1000. And why? Because if you subtract this also, 15,000 minus 500, this will be relative, and because this is in opposite direction, it will be minus 1000. So this seems very obvious here, but this has to be taken. This has to be used in a way which has been taught to us. So the negative sign indicate that the direction of its products of combustion is opposite to the direction of motion of the jet airplane. A car moving along a straight highway with speed 126 km an hour is brought to a stop within a distance of 200 meters. So distance is given, the speed is given, and rest, that means it is coming at rest. So initial velocity is this, final velocity is 0. What is the retardation? We have to find A, that is deceleration. How long does it take for the car to stop? So we'll simply use the formula. The initial velocity is 126 km an hour, multiply it by 5 by 18. You get in 35 meter per second, which is in conversion from kilometer per hour to meter per second. Just multiply this by 5 by 18. As I said, the final velocity has to be 0 because it is coming at rest. Now, what is the distance covered by the car? It is given as 200 meters. We assume it to be A. The retardation acceleration in the negative direction is A. Now, we know that the equation of motion V square is equal to U square plus 2AS. Put these value, you get A equal to minus, because this is deceleration, you get minus 3.06. Again, we'll use the first equation of motion V equal to U plus AT. Put this value, okay. A you know, V and U you know. So this will be 11.44 seconds. Two trains A and B of length 400 meter, each are moving on two parallel tracks with a speed of this, in the same direction, with A ahead of B. You can say that there are two parallel tracks, and one is moving like this, other is moving like this. The driver of B decides to overtake A and accelerates by 1 meter per second square. If after 50 seconds the guard of B just brushes past the driver of A, what was the original distance between them? So after 50 seconds, this is very important, this has to be taken into account in the question, that after 50 seconds when he increases the speed of one, or you can say acceleration to 1 meter per second square, or attain 1 meter per second square acceleration, after 50 seconds this guy sees the back of the train, or you can say the driver sees the guard. So what is happening here is, first we will start with train A. The initial velocity is 72 km per hour, multiplied by 5 by 18, you get 20 meter per second. Time is 50 seconds, acceleration is 0 for this one. There is no acceleration. The acceleration is for B. Okay. So we'll use the second equation of motion. We'll use S1 equal to ut plus half a t square. A1 t square, you can say. A1 is 0. So just multiply 50 with 20, you get 1000 meters. So in this time 50 seconds, the train A has moved 1 kilometer. But when we are talking about train B, again the speed is same, 72 km an hour. So this will be in meter per second, 20 meter per second. But this train is having an acceleration of 1, and time is again same as the previous one, 50 seconds. So we'll apply the second equation of motion, S equal to ut plus half a t square. We will apply this, and we see that it is 2250. Now 2250 A has moved, 1000 B has moved. So how far this has moved, or how far this is ahead? This is, or you can say what was the initial distance? Just subtract these two, you get 1250. On a two-lane road, car A is traveling with a speed of 36 km an hour. Two cars B and C approach A in opposite direction. So A is here. Say B is coming from this side and C is coming from this side. And say A is moving like this. A and B are in the same direction. C is on this direction. The speed of these two, B and C, is given as 54 km an hour. At certain instance, when the distance AB and AC are equal, that means this distance is equal to this distance, both being 1 kilometer. So this is also 1 kilometer, this is also 1 kilometer. B wants to decide that, okay, I want to overtake A before C does, because they are coming in the opposite direction. So B has to attain certain speed or acceleration, something, so that there is no collision. So B has to surpass this before C reaches here. So what will we see here? Velocity of car A is 36 km an hour. Multiply it by 5 by 18, you get 10 meter per second. How about car B? VB is 54 km an hour, which is 15 meter per second. The velocity of car C will be again same thing, so 15 meter per second, because B and C are having the same speed. Now what is the relative velocity of car B with respect to A? Because these are in opposite direction, right? So one is coming at 15, this and you can say that when you are comparing B with A, so it will be VB minus VA. One is having 15, other is having 10, so it will be 5 meter per second. But when we are talking about C and A, then we say, okay, because they both are in this direction. When they are coming, because one is, if this is taken as plus, this has to be taken as minus. So in this case, we'll take minus VA. The speed will increase. When they are opposite, the speed increases. So VC minus VA, this is the relative velocity of C with respect to A. 15 plus 10, that is 25 meter per second. But we know that the distance between AC and AB are 1000 meter, 1 kilometer. So time taken, because C is at constant or uniform speed, you just have to find out 1000 by 25. That is, you have to find T equal to distance by speed. So this is 40 seconds. Now this is very important. At this time, 40 seconds, this car reaches to this car. But the thing is that this car wants to overtake. So in this 40 seconds, which car this wants, this is coming here. In this 40 seconds, in order to avoid an accident, the car must cover the same distance in a maximum of 40 seconds. And the second equation of motion, minimum acceleration, we can obtain it as like this: x equal to ut plus half at square. So the distance he has to cover is 1 kilometer. But the speed, we know 5 into 40, that 5 is there. But 40 is the time. In this time, he has to do something, or some acceleration has to be there. So what is the proper acceleration? A has to be found out using this formula. It will be 1 meter per second square. Two towns A and B are connected by a regular bus service, with a bus leaving in either direction every t minutes. So say A here, B here, every time in t minutes, bus starts from here, bus starts from here. Now A man which is cycling with a speed of 20 km an hour. Say somebody is cycling also 20 km an hour in the direction A to B. Notices that the bus goes past him every 80 minutes in the direction of his motion. So the bus moving like this will be every 80 minute difference. But the bus which are coming from here, they pass every 6 minutes in the opposite direction. So what is the period T of the bus service, and with what speed do the bus ply on the road? So what we will do here is, if let us take capital V is the speed of the bus which are running from A to B, which are given as the normal speed of the buses. The speed of the cyclist is given as 20 km an hour. What is the relative speed bus which are moving in the direction of the cyclist? So when the relative speed bus which are moving in the direction of cyclist, it will be V minus V, that is V minus 20. And the bus are passing every 18 minute. So 18 minute will be 18 by 60 hour. What is the distance traveled? Distance traveled is simply velocity into time. So this will be the first equation. Now since every bus leave after t minutes, it is given every t minute it passes, the distance traveled by the bus will be equal to V into t by 60, right? Now both equation, these two are equal, so let us equate them. This is equal to this. Let us talk about the other aspect. The relative speed of the bus moving in the opposite direction. Cyclist is moving like this, the bus is coming like this. So the relative velocity will be V minus of minus 20, that is V plus 20. The time taken means every 6 minutes he sees a bus. 6 minutes will be 6 by 60 hour. And what will be the scenario? The time it was Vt by 60, because every t minutes also this is coming. So this will be V in Vt by 60 again, but here V into 20, V plus 20 into 6 by 60 will be equal to Vt by 60, as we did in the previous which was on the same direction of the cyclist. Now let us equate this equation with this equation. That is equated. When we equate it, we find V equal to 40. And just substitute this in any of these, this one or previous one, we get time equal to 9 minutes. A player throws ball upward with the initial velocity 29.4. Like this. It throws. What is the direction of acceleration during the upward motion of the ball? So gravity is like this, so it is on the opposite direction. What are the velocity and acceleration of the ball at the highest point of its action? So at highest point it goes and it comes back. So here the velocity will be 0. It will take rest for very short span, but the acceleration is always there. It is gravity. We have to choose x equal to 0 and t equal to 0 to be the location and time of the ball at its highest point, vertically downward direction to be the positive direction of x-axis, and give the signs of position, velocity, acceleration of the ball during the upward and the downward motion. To what height does the ball rise, and after how long does the ball return to the player's hand? G is given as 9.8 and neglect air resistance. What is happening here is the direction of the acceleration, as I said, is always to the center of the earth, and because there is a upward motion, the acceleration will be downward. So velocity is 0, acceleration equal to 9.8. X is greater than 0 when it is going up and down. V is less than 0 for up. V is greater than 0 for down, because here it is going to stop at some time, and here it is going to, because of acceleration, it will gain some speed. And acceleration is greater than 0, which is actually 9.8 constant value throughout the motion. And what is this? This is the time. I'll show you how it comes. So this is all the discussion which I just told you. Let us come to the computation part. So when it goes up, the initial velocity is given as the 29.4 meter per second. Final velocity has to be 0 because it is going to stop. The acceleration is, because it is always on the downward direction, acceleration will be minus z. It is minus 9.8 meter per second square. And we'll apply the third equation of motion, v square equal to u square plus 2gs, and s will be simply like this. We'll just put the values, and this will be 44.1 meter. And we know that the time of ascent is equal to time of descent. We can apply v equal to u plus at, and the time will be 3 seconds. I leave it for you, but when it goes up 3 seconds, it comes down, it is 3 seconds, 3 plus 3 is 6 seconds. Read each of the statement below carefully and state with reason and example if it is true or false. A particle is in one-dimension motion with zero speed at an instant may have non-zero acceleration at that instant. With zero speed may have non-zero velocity. With constant speed must have zero acceleration. With positive value of acceleration must be speeding up. So first one is our true, second is false, then true, then false. So let us see how does it happen. True, false, true, false. First is with zero speed at an instant may have non-zero acceleration at that instant. So when an object is thrown vertically up in the air, it becomes 0 at maximum height. But at this point also the acceleration is 9.8 due to gravity, which is acting on the downward direction. First one. Second is this one. With zero speed may have non-zero velocity. So speed is the magnitude of velocity we know, and when the speed is 0, the magnitude of the velocity along with the velocity is 0. That is why it is false. A car moving on a straight highway with constant speed will have constant velocity. Since the acceleration is defined as the rate of change of velocity, the acceleration of the car is also 0. That is why it is true. How about this one? See, this statement is false. With positive value of acceleration must be speeding up. So the statement is false in this situation when the acceleration is positive, velocity is negative at any instant of time you take from the origin. So for all the time before velocity becomes 0, there is, the particle is slowing down. So such a case will happen when a particle is projected upwards. And this statement is true, that is, when both velocity and acceleration are positive at the time taken as origin. So this case happens when a particle is moving with a positive acceleration and falling vertically downward in this case, right? A ball is dropped from height 90 meter on a floor. At each collision with the floor, the ball loses 1/10 of its speed. That means 9/10 of the speed is remaining, or it remains. We have to plot the speed time graph of its motion between t equal to 0 to 12 seconds. So this is what is happening. That is, we have taken from 0 to 12. This is in hours, so we took 0 to 12. and these are the speed. We'll know how this speed is going to come. We'll use some formula, etc. But this is the graph of the object or ball falling. This is speed time graph. So what is happening? The ball is dropped from height. So height is given as 90 meter. We'll take like this. Initial velocity, because it is coming from the rest or starting from the rest, the initial velocity is 0. There is an acceleration because the ball is dropping. Acceleration due to gravity is also in the same direction. So we'll take A as positive 9.8 meter per second square. But the final velocity is not known to us, which is V. Let us use the second equation of motion in order to find out the time. We'll put all these value in s equal to ut plus half a t square, and when we find out the time, it will be 4.29 seconds. We'll use again this equation, first equation of motion, v equal to u plus at, in order to find out the velocity. What is the velocity? So time we have found out, just put it here. U and a we know. So the velocity comes to be 42.04. Now it is being said that once it collides, then it retains 9 by 10th speed, that is, it loses 1/10. So 9 by 10 of this 42.04 will be what? 37.84, right? So this is the value which has come. Now time taken by the ball in order to reach maximum height is obtained by the equation v equal to ur plus at. Now the initial velocity will use as the velocity we have just found, that is 9/10 of 42 something. Acceleration is always 9.8, but in this case first it hits and then again goes back. So now the direction has changed. The acceleration is like this, gravity. So we'll use minus this, and again it is going to be at rest so that it comes back. So the final velocity will be 0. Initial velocity is 9/10 of the velocity we found, and the gravity will be minus 9.8. So what will be the time t dash? It will be 3.86. If you find this out, it will be 3.86. So what will be this t plus t dash? It will be 8.15 seconds. The time of ascent is equal to the time of descent. So the ball takes 3.86. So it goes up and then it goes down. So 3.86 is again the time for the next striking of the floor. The velocity with which the ball rebounds from the floor, again we have this speed now. This will be the initial speed for the second rebound. 37.84, 9/10 will take, this will be 34.05 meter per second. And again the speed, or you can say the time was this, and 3.86 was the time. We have to add this so that the time taken by the ball for the second rebound can be found out, that is 12.01 seconds. And this is the speed time graph of all the values which we found out. This is starting, we have just given a kink because the speed is starting from this, so 34 to 42 will take, and from here we'll go up to 20 because we just have to find out till 12. So this is how it is going. The speed was 42, then it came like this speed 37.84, then it came like this, because at this point when it reaches height it becomes 0. Then again it goes back till 12, this t equal to 12, and the speed would be 34.05. Explain clearly with example the distinction between magnitude of displacement, also called the distance, over an interval of time, and the total path length covered by particle over the same interval. So the magnitude of displacement over this is the shortest distance, that is the straight line, or you can say perpendicular distance between the initial and final position, whereas the total path length is the actual path covered by the particle in that particular time. So if you go like this, come here, go like this, so this plus this is the path length, but this and this means this distance is your perpendicular distance, which is, this distance is displacement. Suppose we have, let us take one more example. We have a particle which moves from A to B, then comes back to point C. So it A here, B here, and C is here at some time t. The magnitude of the displacement of the particle will be what? This AB, then BC, AB plus BC. And we should know that the magnitude of displacement can never be greater than the total path length. It can be total path length can be equal or greater than the displacement. So both the quantities may be equal at some time. The next part is magnitude of average velocity over a time interval and the average speed over the same interval. So what is the average velocity and average speed? And then we have to talk about the greaterness of the quantities as well. So what is the magnitude of average velocity? It has to be displacement by time interval. For any particle, say average velocity here. When we talk about the displacement, it has gone from A to B, then came back at C. So initial and final position is A and C. So we'll say AC by T. But when we talk about average speed, we have to take total path length. So we have to take first AB and then we have to add BC also. The total path length by time interval is AB plus BC by T, and this AB plus BC has to be greater than AC, or it is greater than AC. So average speed is greater than the magnitude of average velocity, and these two quantity will be equal if the particle continues to move along a straight line. Now the next question is, a man walks on a straight road from his home to market 2.5 km away with a speed of 5 km an hour. So here he goes up to 2.5 km and the speed is 5. Finding the market close, he instantly, without waiting, he returns back to home. Now the speed has changed to 7.5. The distance remains the same, 2.5. Again 2.5 is the distance, speed is 7.5. So what is the magnitude of average velocity? Average speed of the man over the interval of time, 0 to 30 minutes, 0 to 50 minutes and 0 to 40 minutes. So time taken by the man to reach the market, see, speed equal to distance by time. In order to find time, it will take as time equal to distance by speed. What is the distance from here to here? 2.5 km. What is the speed? 5. Initially the speed was 5. So 2.5 by 5 is half hour, which is 30 minutes. Now when he is returning back, the distance remains the same, but the speed increases to 7.5. It will be 1 by 3 hours, that is 20 minutes. So what is the total time? This 30 minutes plus 20 minutes, which is 50 minutes. Let us find the velocity now. Velocity is displacement by time and average speed is distance by time. In the first case, from here to here, it is 2.5 distance by half hour, right? 5 km per hour. Average speed is distance by time. Again, this is again 2.5 km and again half hour is being taken. So we are talking about the first case. This is again 5 km per hour. So we see velocity and speed are equal here. Total time is 50 minutes. Let us divide this by 60 so that we can get it in hour. But what is the net displacement? He starts and he comes back again. So initial and final position are same. So displacement is 0. But total distance is 2.5 here, 2.5 here. So it becomes 5 km. What is the average velocity? It is displacement by time. Displacement is 0. It becomes 0. What is average speed? This is distance by time. Distance is 5. And what is the time? This is 5 by 6 hours, 50 minutes in all. So this will be 6 km an hour. Now the speed of the man while returning back is 7.5 km. And distance traveled in the first 30 minutes is what? From here to here, it is 2.5 km. So what is the distance traveled by the man in next 10 minutes? 30 minutes is okay, but for next 10 minutes, 7.5, the speed of the man when he is coming back, because 30 minutes he has passed here with certain speed. Now when he comes back, the speed changes to 7.5. So 7.5 into 10 minutes, 10 by 60, that is 1.25 km. Now he has come 1.25 meter here on this side. 2.5 is total distance. So what is the displacement from this point to this point, which is 2.5 minus 1.25, which is 1.25. But what is the distance traveled? 2.5 is this one, distance we are talking about. 1.25 is this one. So in all, total distance traveled will be 3.75. Now let us again find the average velocity and average speed. Average velocity will be this distance, displacement, divided by the time, which is 40 minutes, so 40 by 60. The average speed is, because the distance we are going to take 3.75, again 40 minutes, that is 40 by 60. So this gives you average speed. We have carefully distinguished in the previous discussion between average speed and magnitude of average velocity. No such distinction is necessary when we consider instantaneous speed and magnitude of the velocity. So the instantaneous speed is always equal to the magnitude of instantaneous velocity, y. The idea is the instantaneous velocity, if the path is like this, if we take an interval, we find the average speed or average velocity. But when we have to find at certain point, some specific point, we have to find out the velocity or speed, we call it as instantaneous velocity, and instantaneous velocity is simply the first derivative of distance with respect to time. So ln is dx by dt. So the time interval, this dt is so small, it's very small, that the particle is assumed that it doesn't change the direction of the motion because it is very small. How can you explain the change in direction of motion in such a small time? So both path length and magnitude of displacement here becomes equal in this time interval. That is why the instantaneous speed is always equal to instantaneous velocity. We have certain graphs. We have to state with reason which of these cannot possibly represent two one-dimensional motion of a particle. When we are talking about one-dimensional motion, we have to understand that at same time the particle cannot be in two positions. See, at this time this particle is at this point, and see this one v1. If you draw a time, so say certain time, it is in two position, right? Here the speed, this is a graph where something is increasing but something is decreasing also. Whether it can decrease, this is total path length. Can total path length decrease? If you go here from here, this total path length, it adds up, so it is not going to decrease anytime. So you can see that these three are outrightly discarded. So let us take one by one, then discuss it again. In this xt graph, this is a graph does not represent one-dimensional 1D motion of the particle. Why? Because this has at the same instant of time two positions. Similar case is with this. It also does not represent one-dimensional because particle can never have two positions or two velocities at the same instant of time. In this case, it does not again represent one-dimensional motion. Why? Because speed and t, this is a scalar quantity, and scalar quantity, how can it be negative? It cannot be negative. And this case, it is path length by time. Path length can never be negative. Path length has to add up. It has to add up. So it will go like this only. It will never come down. In this figure, this shows the xt plot of one-dimensional particle motion. Is it correct to say that the particle moves in a straight line for t less than 0 or on a parabolic path for t greater than 0? If not, suggest a suitable physical context for this graph. The answer is outright no. The xt graph of particle moving in a straight line for time which is less than 0 and on a parabolic path like this for t greater than 0, it cannot be shown like this. Why? Because this particle does not follow a trajectory of path followed by the particle which is t equal to 0, x equal to 0. And a physical situation is which resembles this is an object which is falling freely and from certain height. A police van moving on a highway with a speed of 30 km fires a bullet at a thief car. So police is here, thief is here, it is firing some bullet, speeding away in the same direction. So both are moving in the same direction. Now the bullet speed is 192, coming from 192 km an hour, going which is this speed, the speed of the thief car, and police van is very slow, but the muzzle speed of bullet is very fast, 150 meter per second. So with what speed does the bullet hit the thief car? The answer lies in the relative version. The speed of police van 30 km per hour multiplied by 5 by 18 in order to get meter per second. The muzzle speed is Vb, that is, we take it as Vb, that is 150 meter per second. It is already given. Speed of thief car is 192 km an hour multiplied by 5 by 18, you get 53.33. Now since it is this, you can say revolver is inside this van or police van, this police van is already moving with a velocity of 8.33 and the velocity is 150 of the muzzle. So this velocity will add up. So 150 plus 8.33 will be the actual velocity of the bullet being fired. And now both vehicles are moving in the same direction. So velocity with which the bullet hits the thief car will be simply Vbt, Vb minus Vt, 158.33 minus 53.3, which is 105 meter per second. You have to suggest a suitable physical situation for each of these graph. See, the first graph, this is a xt graph. It shows that body is at rest. Then its velocity increases with time and it attains an instantaneous constant value here. The velocity now then decreases to 0 and it increases with time, right? Then this velocity increases in the opposite direction and it acquires a constant value now. This situation comes where? A football, when it is kicked, say a football is being kicked, it hits and it comes back. This is this physical scenario which can explain this graph. Next is this one. The sign of velocity, it changes and its magnitude decreases with passage of time. This one, it is decreasing. At some time it will become 0. So what will happen if you just throw a ball like this on the floor? So it will jump sometime, after that it is going to come on the rest. So it decreases, the velocity decreases by certain factor, eventually it becomes 0. The last one is, this is a AT graph. This AT graph shows that initially the body is moving with a certain uniform velocity. Its acceleration increases. Now acceleration increases for a short interval of time, then it drops again. What is this is indicating? A body starts moving with some constant velocity. This will come when you hit hammer, a nail with a hammer. This is the physical scenario. In this figure, this is a xt plot of particle executing one-dimensional simple harmonic motion. We'll talk about this in the later discussions sometime, but we'll give you a formula. Give the sign of position, velocity, acceleration variable of the particle at t equal to 0.3 seconds. That means somewhere here. And it is very easy to find out. If this is negative, this is positive, like this. At 1.2, somewhere here, and minus 1.2, somewhere here. So the first is at t equal to 0.3 second, as you see here, 0.3 second. The three things which are being asked is the position and velocity, both are negative. Position and velocity both are negative. But the acceleration is positive here in this case. Then in the second case, we have, because how to find out the acceleration? Acceleration of simple harmonic motion SHM is given by a equal to minus omega square x, where this omega is angular frequency. So on this basis, we'll find out the acceleration. This position and velocity is quite easy to find out from xt graph. In this second interval, which is the second one, which is this one, t equal to 1.2 second, the position and velocity, they both are positive. But if you put the value in this acceleration value, you get minus, that is negative. In the third one, which is t equal to minus 1.2, the time interval in this x is negative now. And the slope of this xt graph gives what? It is negative at this point. And both x and t are negative. The velocity becomes positive. And if you put the values here, it can be found that acceleration of the particle will be positive. In this figure, it gives xt plot again, the particle in one dimension. Three different equal intervals of time are shown, 1, 2 and 3. In which interval is the average speed greatest and in which it is least. Also give the sign of average velocity for each interval. In xt graph, velocity can be found out using you can take the tangent, or you can take any tangent and slope of that will be giving you, that is dx by dt or delta x by dt, that is going to give you velocity. Now in the first case, you see in the interval 3, it is greatest, the greatest speed has been asked. So in interval 3 it is greatest, in interval 2 it is least, in the interval 1 and 2 we have certain things which are positive, that is in the third one we have negative. What is positive, what is negative, let me tell you. Now the average speed of a particle, this is shown in xt graph. How to obtain this? We have to find the slope of a graph in a particular interval of time. Now from the graph, the slope is maximum and minimum at 3 and 2. See, this is the maximum slope, and then this is this is the minimum slope. It has more slope. These two have more slope than this one. So this is minimum, this is maximum. So average speed of a particle is greatest in the interval 3 and least in interval this one. This is very clear. Now how about the sign? The sign of average velocity is positive in interval 1 and 2. So because this is above, 1 and 2 are positive. In 3 it is negative, right? Because it is on the downside. And the value, which is the slope, is also coming negative. Figure 3.25, this figure shows a speed time graph of a particle in motion along a constant direction. 3 equal intervals of time are shown, 1, 2, 3. In which interval is the average acceleration greatest in magnitude? In which interval is the average speed greatest? We have to choose the positive direction as constant direction of motion. We have to give signs to V and A in the 3 intervals. And what are the acceleration at point A, B, C, D? A, B, C and D. See, first of all, this is speed time. So what is the acceleration? This is given by dx by dt. So average acceleration in this interval 2 is greatest. Average speed in this interval 3, this one, is greatest. Average acceleration is greatest in 2. Average speed is greatest in 3. V is positive in 1, 2, 3 because you are getting a positive slope. And 1 and 3. 1, 2, 3. And in acceleration, 1 and 3, these are negative. And interval 2, right? This 1 and positive in 1 and 3 and negative in 2, this interval. How? You just have to take the, find out these d2x by dx2. That is what we find out. But let us discuss them. First, let me tell you the background. Acceleration is what? It is given by the slope of speed time graph. That is how I told you these signs. It is given by the slope of the speed particle graph with a given interval of time. It is given here. And when the slope of given speed time graph is maximum in interval 2, because this slope we are talking about. In 2, this is maximum. You are getting maximum slope. Average acceleration will be greatest in this interval. How about the height? The height of the curve, this height of the curve from the time axis, it gives you the average speed because it is speed time graph. So it is clear that the highest is this one. So it is greatest in 3. The average speed of a particle is greatest in this interval 3. So first of all, let us talk about interval 1. The slope of the speed graph is positive here. You see this, if I drop a tangent, it is positive. So the acceleration is positive. The speed of the particle is also positive in this interval. When we go to this second interval, this is the slope of the speed time. See, this slope is negative. So acceleration is negative. But the speed is positive because it is a scalar quantity. When you come to this one, the slope of this one is 0. This is slope which is 0. So acceleration is 0 in this interval. But the particle is acquiring some uniform speed. So that is the positive. It is positive in this interval speed. But at A, at B, at C and at D, all these points we have line parallel to time axis. So slope is 0 at these points. So A, B, C, D, at these points acceleration of the particle is 0. So these were question and answered on motion in a straight line. Thank you so much. Take care of yourself.